Welcome everyone to my new video. Now I'm gonna show you what is a NOT gate or an invert gate. The invert or a NOT gate is one of the most fundamental logic gates in digital electronics. Here on the left side you have the symbol of a NOT gate. A NOT gate or an inverter outputs a logic level that's the opposite or the complement of the logic uh, input. So if you have an input of a 0, you will have an output of 1. If you have 1 or a high state, you will have a low state. Here is a switch analogy and here is a transistor analogy. But I'm gonna show you that in a program called Proteus. So now, first here is this schematic over here. This is the symbol of an NOT gate in digital electronics. So when I run a program, uh, here I have on the input a low state, and when the simulation is turned on, I would have to have a high state on the output. Just a second, it's running a little slow. Okay, now you see if I have a 0 on the input, I will have 1 on the output. If I have 1 on the input, I would have a 0 on the output. Here in my uh, next schematic, this is a switch analogy to the logic uh, inverter or a logic NOT gate. So uh, when I open the switch, that acts if I put a current that goes into the base. Then the transistor is going to conduct. So here in the output I will have a 0. But if the base doesn't have any uh, current, or if the input is at 0, this here is going to have 5 volts and it's going to be high. So it acts as a NOT gate. So when I'm just gonna stop the simulation for a second. Now I brought here a 5 volt. I brought here a supply of 5 volts, and now in first uh, situation I'm going to bring 5 volts into the base. So this is on a high state. So when I run the program, uh, so now when I run the program, as you can see, the transistor conducts. So here the voltage is in reference with the ground 0.03 volts. So that's that is a 0 output because it's a very small amount of voltage. So it doesn't necessarily, there are ranges in digital electronics that some circuits uh, uh, act as a high or a low state. So for this now is a low state. Now when I bring, if I don't bring any voltage on the base, if I only have a zero input, now I would have a high output. I would have 5 volts here on the output as shown in the circuit in this transistor analogy. So uh, that the program just run itself. So when there is no current going into the base of the NPN transistor, the transistor will block the current from going to the collector through the emitter, and here we will have the 5 volt output. That's the same amount of output as here on this power source on the collector. So thank you for watching and see you in my next tutorial.